Hello students, welcome back. Previously we went through some indefinite integrals with substitution. Now let's do some definite integrals with substitution. How do you do things like this or this? Well, one way to do that is to complete a problem and find out the indefinite integral and plug in y equals to 2, plug in y equals to 1, subtract from the other. Or in this case, plug in x equals to 1 and plug in x equals to 0 and subtract from the other, and that's it. And those are solution 1. Use the substitution. Take the derivative, so for dy, substitution 1 and 2, and complete the problem. And all the way to the end and get y expression here. So substitution 1, 2, and 3 all there. And then using this final expression, go ahead with the fundamental theorem of calculus. Plug in 2, plug in 1, subtract from the other, and work out, you get the answer. It works well with calculus 1, and most of the time it works well for calculus 2 as well. So for us, this is going to be the preferred solution. Here's another example. Just go ahead with the substitution as before. Substitution, derivative computation, and so for the x, right? Substitutions 1 and 2, and then calculate the integral, and then substitution number 3 to get the final answer. Here, I didn't bother with plus c because I'm not going to use plus c, as you see down below. Plug in 1, plug in 0, subtract from the other using the fundamental theorem. Plus c will disappear one way or the other, and we get the answer. Here's another problem. Oh, this is left to the students. Okay, never mind about that then. Now, if you want another solution, and somehow if you want another solution that works all the time, including multivariable calculus, or every single time, no exception, then you can go with solution 2, but be warned, it's not easy. So do the same substitution, and then we change the starting and ending point of the interval. Y equals to 1 means u is 3 because u is y squared plus 2y. Plug in y equals 1 there. And y is 2, then u is 8. So this integral where y is moving from 1 to 2 is same as u integral where u is moving from 3 to 8. So instead of getting the y expressions back in, calculate the u integral and then just plug in u equals to 8 and u equals to 3 and subtract from the other and go ahead. Because of this consideration here, most students find it harder to do it this way. But if you get used to that, this is easier, takes less step of computation, and moreover, this one works all the time. Previous method doesn't work for multivariable, but this one does. Another example here. Do the substitution, okay, all right. Do the integration. And then x is moving from 0 to 1. Okay, how about y? Plug in x equals to 1, plug in x equals to 0, you get y going to 1, and plug in x equals to 1, you go y going to 2. So instead of moving x going from 0 to 1, we move y from 1 to 2, and then use fundamental theorem from there. Tricky? Yes, I agree. So I'm not going to emphasize it too much here. First method will be sufficient for this course. Some area problems with substitution. How about this one? Okay, all right. You calculate the area using integration by substitution. So you have to set up the integral. But then again, if you integrate from -1 to +1, and you're going to get 0 because negative area, positive area will cancel each other out. How do you do that? Well, I'll look at the symmetry and find out this area and simply double it. Yep. this is the integral I'm going to do. So how do you do this integral? Take the substitution and then go from there. U as 1 minus x squared, take the derivative and then dx. And then do the integral computation and then double it. I use a second method here. If you use this first method, it'll be fine. A bit harder problem. Okay, this one is going to be harder because in order to find out this integral here, for the right hand side, this positive area before doubling it, you're going to get an integration by substitution, a set of 4 integration, because you're going to have some leftover x squared flying around. You see, you have this extra x squared to work out, and that is 1 minus u, so you need some extra work. I'll stop here and leave the rest to the students. It's just integration by substitution, complete the problem, and then apply the fundamental theorem. So it's not too bad. Not bad at all. So it's just a trivial application after substitution. No big deal there. I'll stop here.